Hello everyone. In today's class, we're going to learn how to write Maxima program for evaluating indeterminate forms. As we all know, the simplest indeterminate forms are 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power of 0, 1 to the power of infinity, and infinity to the power of 0. Because see why these are called as indeterminates. It's not going to give you a unique value. For example, see here. See, 0 by any number, we know that it is 0. Whereas any number by infinity is, any number by 0 is infinity. So it can be represented, or it can be taking two values here. Or you know that number by itself is 1. So 0 by 0 is 1. So we can write this one in three ways. That's why it is not possible to find which one is true, right? Similarly here, infinity by infinity, that number by itself is 1, whereas infinity by anything is infinity, and we know that any number by infinity is 0. So it has three choice. We cannot determine which one is true. Similarly here, you know that 0 into any number is 0, whereas infinity into any number is infinity. So this has got two choices, and we cannot determine which one is true. Similarly here, that number minus itself is 0, whereas we know that infinity minus any number is infinity. So it has got two choices, and we cannot determine which one is true for this. Similarly, 0 to the power of 0, we know that any number to the power of 0 is 1, whereas 0 to the power of anything is 0. So this number has got two choices. Similarly here, 1 to the power of infinity means we know that 1 to the power of any number is 1, whereas any number to the power of infinity is infinity. So this one also has got two choices. Similarly here, infinity to the power of 0 means we know that infinity to any power is infinity, whereas any number to the power of 0 is 1. So this has also got two choices. That means in all these cases, it's not possible to find exact value. That's why they're called as indeterminate forms. And to solve these indeterminate forms, we know we have to apply L'Hopital's rule. So when you get a limit, after evaluating the limit, if you are resulting in these indeterminate forms, then you have to apply L'Hopital's rule. What L'Hopital's rule says, if it is of the form 0 to the power of 0 or infinity to the power of infinity, then you have to differentiate numerator separately and denominator separately until you come to a case where the indeterminate form is absent. Now, what about this 0 into infinity? 0 into infinity as well as infinity minus infinity case, you have to bring them to the form either 0 to the power of 0 or infinity by infinity form. Once after bringing these two into this form, then you know how to solve the indeterminate form having 0 by 0 form or infinity by infinity form. Then for last three cases, you have to assume the limit which is giving you these indeterminate forms as y, and you have to take log on both sides. Then after taking log, you're using the log properties, you have to find the limit of log of the function. Then you'll get some number. Then using that, we can find the limit. So these are the simplest forms used in solving the indeterminate forms which are resulting due to evaluation of limits. Now, how to write Maxima code for this? The general command is very simple. As usual, we start with kill all. That kills all the temporarily stored values or assigned values or assigned functions with the dollar sign. Then limit. Limit of what? Limit of, within this simple bracket, you are to write the function which you are evaluating, okay, and with respect to variable, and at which point you are evaluating the limit. So you need to write all these three separated by comma. That gives you the limit of the function which you are finding. For example, let us see, Write the Maxima program to evaluate limit as x tends to 0, x minus sin x whole divided by x cube, and also solve manually. See, before writing the Maxima program, let us evaluate this manually. What is your given limit? It is limit as x tends to 0 of x minus sin x divided by x cube. Now plug in the limit. What is the limit value? It is x equal to 0. If you put x equal to 0, you'll get 0 minus sin 0 divided by 0. And you know that sin 0 is 0. So 0 minus 0 is 0 divided by 0. So that means this is of the form 0 by 0. That means it is taking indeterminate. And since it is of the form 0 by 0, we can apply L'Hopital's rule. What your L'Hopital's rule says? Differentiate numerator separately and denominator separately. So what is the derivative of x? Derivative of x is 1 minus derivative of sin x is cos x whole divided by derivative of x cube is 3x square. Now we have to check whether the indeterminate form is gone or not. If you plug in the limit, if you put x equal to 0, you'll get cos 0. Cos 0 is 1. So 1 minus 1 gives you 0 divided by 3 into 0 is 0. So again it is of the form 0 by 0. So once again we have to apply L'Hopital's rule. That means differentiate numerator separately. What is the derivative of 1? 0 minus derivative of cos x is minus sin x. So minus into minus plus sin x divided by derivative of x square is 2x. 2 into 3 is 6x. Let's take out this 1 by 6 outside because it's a constant. It will not make any changes in the answer. So let us keep that 1 by 6 outside. Then you left out with limit as x tends to 0 sin x by x. And we know that this is a standard limit. And limit of this one is 1. So substitute it, you'll get 1 by 6. Therefore, the solution of this is 1 by 6. Now, how to write Maxima program for this? Very simple. We start with kilol. Since it is of the form 0 by 0, take numerator as f of x, denominator as g of x. So that your f of x will be x minus sin of x, right, with semicolon, because I just want to display this. And since it's a function, you have to use functional assignment operator, that is colon with equal sign. And g of x, which is colon with equal sign, is equal to, what is your denominator? Your denominator is x cube, which should be written as x cap 3 with colon. Now, let us find the limit of this. Limit of, within simple bracket you have to write, what is your numerator? F of x divided by denominator is g of x, comma, what is your variable? It's x, comma, and at which point you are finding the limit? 0, right? Stop with semicolon. This gives you limit of this. Fine. Let's move on to next problem. Write the Maxima program to evaluate limit as x tends to pi by 2 tan x by tan 3x and also solve manually. Now see here, if you apply the limit for this, you'll get tan pi by 2 divided by tan 3 pi by 2. And tan pi by 2 is infinity. Whereas tan 3 pi by 2 is same as minus cot 0. And cot 0 is infinity. So this is infinity by infinity form. And for solving this, what we do is we call this answer, right, after evaluation of this as some I. Because we are having tan x and tan 3x and both are not going to vanish at any point. So we'll do, we call this limit as some I. Now, since this is of the form infinity by infinity, we apply L'Hopital's rule. By L'Hopital's rule, differentiate numerator separately and denominator separately. What is the derivative of tan x? Secant square x divided by derivative of tan is secant square 3x into, forget tan, derivative of 3x is 3. So you'll get 3 secant square 3x in the denominator. Now if you put x equal to pi by 2, you will get secant square pi by 2. And we know that secant is nothing but 1 by cos. So what is cos pi by 2? Cos pi by 2 is 0. So 1 by 0 is infinity. So in the numerator, you will get infinity. Similarly, in the denominator also, you will get infinity. Therefore, this is infinity by infinity form. Now, once again, apply L'Hopital's rule. So by L'Hopital's rule, right, derivative of secant square x is 2 into secant x into, forget power, derivative of secant x is secant x into tan x, whole divided by, keep this 3 as it is. Derivative of secant square is 2 into secant 3x into derivative of secant 3x is secant 3x into tan 3x. Forget secant, derivative of 3x is 3. Right? Derivative of 3x is 3. Now, let me take out 1 by 3 outside. And secant x into secant x is secant square x. And these two get cancelled. Secant 3x into secant 3x is secant square 3x. Let me write this one as two limits. See, anyhow, you're going to plug x equal to pi by 2, either for whole or separately. That will not make any harm, because you're going to substitute x equal to pi by 2 only. Whether you're going to substitute at a time or separately will not make any changes. That's why I've written this one as two limits. That means I'm applying limit for secant square x by 3 secant square 3x separately, and limit as x tends to pi by 2 tan x by tan 3x separately. But you know that from the above discussions, your limit as x tends to pi by 2 tan x by tan 3x is I. Similarly, limit as x tends to pi by 2 secant square x by 3 secant square 3x is I. So let me substitute that. So 1 by 3 into I into I, and you know that your left hand side is also I. So 1 I get cancels. Is that right? So you'll get I square, I is equal to, this should be 3. Right? So this is equal to 3. So your limit as x tends to pi by 2 tan x by tan 3x is 3. This is how you have to evaluate. Now, how to write Maxima program for this? As usual, kill all. What is your f of x? Colon with equal sign tan of x, that is numerator, because it is of the form infinity by infinity. So numerator is f of x, denominator is g of x, that is tan of 3 into x, and limit f of x divided by g of x separated by comma with percentage pi by 2. That is the limit at which you are finding. Okay. Now this is how you have to solve the problem. Okay. Now let's move on to next problem. Write the Maxima program to evaluate limit as x tends to 0, x log tan x, and also solve manually. Remember, if you put x equal to 0 in this, you'll get 0 into log tan 0. And tan 0 is 0 and log 0 is infinity. So this is of the form 0 into infinity. And whenever 0 into infinity or infinity minus infinity comes, you have to bring that one to the form either 0 by 0 form or infinity by infinity form. Since you are having log here, I don't want to send this log to denominator. So I'll bring this one to infinity by infinity form. How? Send this x to denominator so that this becomes 1 by x. If you send 1 by x to numerator, you'll get the old result itself. Old equation. Right? Now, if you put x equal to 0, you'll get infinity by infinity form. So apply L'Hopital's rule. What do your L'Hopital's rule says? Derivative of log is 1 by tan x, and derivative of tan x is secant square x, divided by derivative of 1 by x is minus 1 by x square. Now we know that 1 by tan is cot x, and cot x can be written as cos x by sin x, and secant square x is 1 by cos square x. 1 cos x get cancels here, right? So you'll get 1 by sin x into cos x divided by minus 1 by x square. If you send 1 by x square to numerator, that becomes x square by 1. So you'll get x square here, right? And what is your sin x into cos x? It is sin 2x by 2. And if you send this one to numerator, you'll get minus 2x by 2x square by sin 2x. Now, if you apply the limit, you'll get 0 by 0 form. So again, apply L'Hopital's rule. By L'Hopital's rule, derivative of x square is 2x. So 2 into minus 2 is minus 4x. and derivative of sine is cos 2x into derivative of 2x is 2. And 2 2s are 4 you will get. Now if you apply the limit, you'll get minus 2 into 0 divided by cos 0. And we know that cos 0 is 1. So you'll get 0 by 1, which is 0. We got the answer. Now, since it is of the form 0 into infinity, you have to assume one of them as f of x and the other one as g of x. Okay. So let us assume kilol with dollar sign f of x is assigned with x and g of x is assigned with log of tan of x, comma, limit of f of x into g of x, because it is of the form 0 into infinity, comma, x, comma, 0 with semicolon, and that gives you the answer. Now let's see next one. Write the Maxima program to evaluate limit as x tends to pi by 2 secant x minus tan x, and also solve manually. Now see here, you are having secant x minus tan x. If you put x equal to pi by 2, you will get secant pi by 2, which is 1 by cos pi by 2, and cos pi by 2 is 0. So 1 by 0 is infinity, and tan pi by 2 is infinity. So this is of the form infinity minus infinity. So how you are going to bring this one to 0 by 0 form or infinity by infinity form? Just send secant x to denominator. So you'll get 1 by secant x. And tan x to denominator, 1 by tan x. If you send this one to numerator, you'll get tan x. If you send this one to numerator, you'll get secant x. There is no change in the problem. But 1 by secant x is what? Cos x. Minus 1 by tan x is cot x. Take LCM of these two. You will get cot x minus cos x divided by cos x into cot x. Now if you put x equal to pi by 2, you know that cot pi by 2 is 0 and cos pi by 2 is 0. So you will get 0 by 0 form. Hence, we can apply L'Hopital's rule. By L'Hopital's rule, differentiate numerator separately, denominator separately. Derivative of cot x is minus cosecant square x minus derivative of cos x is minus sin x. Minus into minus, that becomes plus sin x. And differentiate denominator separately. Derivative of denominator, you have to apply product rule. Keep cos x as it is. Derivative of cot x is minus cosecant square x plus cot x as it is. Derivative of cos x is minus sin x. Now if you put x equal to pi by 2 here, your cosecant pi by 2 is also 0. Sin pi by 2, you'll get 1. Right? You'll get 1. Oh, sorry. Cosecant pi by 2 is 1. Sin pi by 2 is also 1. So minus 1 plus 1 becomes 0. And here cos pi by 2 is 0. And cot pi by 2 is also 0. So you'll get 0 by 0 form. So we can apply L'Hopital's rule. Again, L'Hopital's rule says differentiate numerator separately. So minus will keep as it is. Derivative of this cosecant square 2 into cosecant x. Forget the power. Derivative of cosecant x is minus cosecant x into cot x plus derivative of sin x is cos x whole divided by. Now apply the product rule for this as well as this. Keep cos x as it is. Derivative of minus cosecant square x is minus 2 into cosecant x into derivative of cosecant x is minus cosecant x into cot x plus cosecant square, keep x as it is. Cos x, derivative of cos x is minus sin x. So minus minus becomes plus here. Then apply the product rule for this. Keep cot x as it is. Derivative of sin x is cos x with minus sin. Minus sin x into derivative of cot x is minus cosecant square x. You simplify this, you'll get this much. If you put x equal to pi by 2 in this, you will get cosecant square pi by 2 which is 1, cot pi by 2 which is 0, cos pi by 2 which is 0 divided by cos pi by 2 0 into anything is 0, cosecant pi by 2 into sin pi by 2 which is 1, so you'll get 2 here, minus cot pi by 2 is 0. So you'll get 0 by 2 which is 0, and this completes the solution. How to write Maxima program for this? Kilol. Remember, this is of the form infinity minus infinity. So you have to assume one of them as f of x and the other one as g of x. So f of x is assigned with secant of x, g of x is assigned with tan of x. Limit of f of x minus g of x, comma x, comma limit at which you are finding pi by 2. So percentage pi by 2 with semicolon. That gives you the limit. Okay. Now let's move on to next problem. Write the Maxima program to evaluate limit as x tends to 0, 1 by x whole to the power of tan x, and also solve manually. As usual, let us consider this. If you put x equal to 0, you'll get 1 by 0, which is infinity. To the power of tan 0 is 0. So this is of the form infinity to the power of 0. So how you're going to solve this one? Anything which is of this form, 0 to the power of 0 or 1 to the power of infinity or infinity to the power of 0, call this limit as some y and take log on both sides. You'll get log y is equal to log of limit of this. And interchange limit and log. So you'll get log of 1 by x equal to 1 by x to the power of tan x. By log property, this is of the form log m to the power of n. So we can take this tan x outside, then tan x into log of 1 by x. Now if you apply the limit, you'll get tan 0, which is 0, into log of infinity, which is infinity. So this is of the form 0 into infinity. And we know how to solve anything which is giving 0 into infinity. We have to convert that into either 0 by 0 form or by infinity form. So let us send this tan x to denominator because we are having log. So let's keep log as it is in the numerator. Log of 1 by x can be written as x to the power of minus 1 divided by, if you send tan x to denominator, that becomes 1 by tan x. Right? And we know that 1 by tan x is cot x. And if you put x equal to 0, then you'll get, see, by log property, I can take this minus 1 outside. So you'll get minus log of x divided by cot x. If you put x equal to 0, then you'll get log 0, which is infinity, divided by cot 0, which is infinity. So this is again infinity by infinity form. Therefore, we can apply L'Hopital's rule. By L'Hopital's rule, differentiate numerator separately and denominator separately. Derivative of log x is 1 by x with minus sign. Derivative of cot x is minus cosecant square x. So minus minus gets cancelled. And 1 by x, if you send that one to numerator, that becomes 1 by x into cosecant square x. If you know that 1 by cosecant square x is sine square x. So you will get limit as x tends to 0, sine square x by x. And if you put x equal to 0, you will get 0 by 0 form. Therefore, again we have to apply L'Hopital's rule. By L'Hopital's rule, derivative of sine square x is 2 into sine x into derivative of sine x is cos x divided by derivative of x is 1. If we apply the limit, because denominator is 1, this is not indeterminate form. So we can apply the limit. If you put x equal to 0 here, sine 0 into anything is, sine 0 is 0. So 0 into anything is 0. 0 by 1 is 0. So what is your left hand side? Log y. Log y is 0. But we want y because your limit is y. Okay. So we need y. So send log to this side. That becomes e to the power of 0. So y is equal to e to the power of 0. E to the power of 0 is 1. Therefore, limit as x tends to 0 of 1 by x to the power of tan x equal to 1. Now, how to write Maxima program? Remember, you have to take the base as f of x and power as g of x in problems of this form. Okay. So, f of x is assigned with 1 by x. G of x is assigned with the tan of x. Limit of f of x to the power of g of x. How you are going to give that one? F of x cap g of x, comma x at the point 0. This ended with semicolon. This gives you the limit of f of x to the power of g of x. Limit as x tends to 0, f of x to the power of g of x. So I had given few more problems. You write the Maxima program and also solve them manually. Now we'll execute all these in Maxima. So kill all as usual. What was our first problem? Our first problem was limit as x tends to 0, x minus sin x divided by x cube. So let us assume numerator as f of x colon with equal sign x minus sin of x, and g of x. What was our g of x? Colon with equal sign x cap 3, and as usual we have to write within limit, because it is f of x divided by g of x, 0 by 0 form, f of x divided by g of x, and variable is x, so you have to separate by comma, and limit at which you are finding is 0. If you evaluate this, see, your answer is 1 by x. That is what we got. And the next problem is, what was next one? Next one was, what was next one?
Tan x by tan 3x.
Tan x by tan 3x, and the limit is, okay, so again it is of the form infinity by infinity. So we have to assume numerator as tan of x divided by tan 3 into x, and the limit is f of x divided by g of x, that is infinity by infinity, and limit at which you are finding is pi by 2. So percentage pi by 2. See, have we got 3?
Yes, sir.
Yes, sir.
Okay, next. What was next one? 0
X into log.
infinity form. X into
Log tan x.
log of tan x.
Tan x.
Okay, at 0. So this is x into, that is f of x into g of x. So f of x into g of x form. So we got 0. Okay. Next, infinity minus infinity form. That is secant x minus tan x. Secant x minus tan x. Right? So this should be f of x minus g of x at x equal to pi by 2. That is percentage pi by 2. Okay. So this gives you 0. Right? Next, after infinity minus infinity, we had infinity to the power of 0. So it is 1 by x, f of x, and g of x is tan x. So this is f of x cap g of x, that is f of x to the power of g of x. So in each of the problem, you have to see which one, in which form you are taking. And limit is x tends to 0. Okay. We got 1. So same answer has been got here. So this is how you have to evaluate the limit using Maxima program. All right, I'll stop at this stage. We'll continue in the next class. Thank you.